Hello, I am Jonathan Maloney, and today I will be talking about the Galilean moons of Jupiter. So it would make sense to start with their discovery. They were discovered by Galileo after he made improvements to the telescope, which allowed for a magnification of 20x. Initially, he had only discovered three bodies, which he thought to be fixed bodies around Jupiter, but later noted a fourth, as well as the fact that they were in orbit around Jupiter. The moons, the common names used for these moons were created by Simon Marius. These names came from the lovers of the Greek god Zeus, who would be the Greeks' equivalent to the Romans' god Jupiter. Those names being Io, Europa, Ganymede, and Callisto. Here you can see on the left, you can see the telescope which was used by Galileo when he had made this discovery. Here we can see positions of bodies around Jupiter on 8 different nights. This is what Galileo noted back when he had made the initial discoveries. Of course, as you can see with the stars' positions, or not stars, the moon's positions moving, it made it clear that these bodies were in orbit around Jupiter, which confirmed that they were definitely not stars and in fact moons. And we may as well start with a comparison of the moons, just basic properties of each. We can start with Io, which is the yellow planet on the left there. It has a diameter of 3,600 kilometers with a mass of 8.93 times 10 to the 22 kilograms and a density of 3.53 grams per centimeters cubed, making it the most dense of the four moons. Europa has a slightly smaller diameter of 3,100 kilometers with about 4.8 times 10 to the 22 kilograms for its mass and a density of 3.01 grams per centimeter cubed. Ganymede, the third planet from the left, is quite a bit larger than the rest, the largest in fact, at 5,200 kilometers, with a mass of 14.8 times 10 to the 22 kilograms, and a density of 1.94 grams per centimeter cubed. And then we have Callisto, the furthest right of the moons, coming in a little smaller than Ganymede, but larger than the rest at 4,820 kilometers and 10.8 times 10 to the 22 kilograms, with the least dense density of 1.83 grams per centimeter cubed. We will come back to why that is so much lower than the rest later when we touch specifically on Callisto. So it would make sense to start with the innermost moon of the four, so we'll start by taking a look at Io. Io is quite large. It is the fourth largest in the solar system, a moon in the solar system, and is marginally larger than Earth's moon. It is considered the most geologically active body in the solar system, containing over 400 active volcanoes, quite a few of which can be seen on the heat scan photo there, with the hotspots showing volcanoes or where volcanic activity occurs. Io is primarily composed of silicate rock surrounding a molten iron core. The bottom right photo there shows that there with that warm silicate, molten silicate around the iron core. Io contains a very thin atmosphere composed of sulfur dioxide and has a period of around Jupiter of 1.8 days. Here we can see a photograph taken by NASA's New Horizons spacecraft as it flew past Io. In the blue on the upper left there is an active volcano on the surface of Io, which is quite Interesting. Next, we'll move on to Europa, the second closest moon to Jupiter, and the smallest of the Galilean moons. It is marginally smaller than Earth's moon and has a bright and smooth surface. This is an icy surface, and it maintains its smoothness and brightness due to a constant supply of new surface ice, because underneath that surface ice is a ocean, which is thought to be around 100 kilometers thick. This subsurface ocean has led to the belief that life could possibly exist within this ocean, just due to the heat from the tidal flexing of Europa due to Jupiter, which keeps the water liquid, which would imply the possibility of life. Europa orbits Jupiter every 3.5 days and is locked by gravity to Jupiter, so the same hemisphere will always face the planet. And Europa is primarily composed of silicate rock, and it has an iron core. Here we can see a close-up on Europa's surface. The crisscross patterns on the surface are thought to be a result of Jupiter's gravity acting on the planet, the tidal flexing, also possibly due to volcanic water eruptions, which would cause gaps in the surface, which would be refilled in with new ice. The reddish-brown coloring seen on the planet here is thought to be caused by sulfur, but has not been confirmed. And Europa's atmosphere is primarily composed of oxygen. Next, we'll be taking a look at Ganymede. Ganymede is the third of the Galilean moons from Jupiter and is the largest moon in the solar system. It is even larger than the planet Mercury, though only about half of its mass. Ganymede is composed primarily of silicate rock as well as water ice, and Ganymede is thought to have a saltwater ocean nearly 200 kilometers below its surface, sandwiched between two layers of ice, as is seen in the top left photo there, with the ice right near the surface and then more ice right before that silicate core. The surface, as seen on the picture on the right, has two different types of terrain, a darker and a lighter. The darker region is heavily cratered, while the younger, lighter region contains quite a few grooves and ridges. Many of the craters on Ganymede's surface aren't visible. This is due to icy crust forming over them. And Ganymede's atmosphere is primarily composed of oxygen as well as possibly ozone. Ganymede has a period of 7 days around Jupiter. Here we could see a photo of Ganymede showing off its magnetic field. Ganymede is actually the only known moon which possesses its own magnetic field. This is thought to be due to convection within Ganymede's liquid iron core. Next, we'll be taking a look at Callisto, which is the fourth of the Galilean moons, or I suppose the last of the Galilean moons, and the second largest after Ganymede. Callisto does not experience the tidal heating that the other moons do. This is just due to Callisto's distance from Jupiter. It is quite far in comparison to the others. Callisto is primarily composed of equal rock and ice. This is why it is the least dense of the Galilean moons. As is seen on the photo on the right, with showing the inner core there, it's composed primarily of equal rock and ice. Callisto also is thought to have a saltwater subsurface ocean, similarly to Ganymede, though not thought to harbor life. quite a bit more dead than the likes of Europa. Callisto is one of the most heavily cratered moons in the solar system, which can definitely be seen from the photo on the left there. You may be wondering what the sparkle is about. It is thought to be that after a impact, which would cause a crater, some water would come up and would sort of cap the crater off with water ice, which would lead to that shine and sparkle seen there. Callisto has a very thin atmosphere, which is composed of carbon dioxide and possibly thought to be also composed of oxygen. And it has a period of 17 days around Jupiter. So, how did we learn all that about the moons of Jupiter? Most of that information had come from NASA's Galileo mission. Of course, named after Galileo himself. The mission launched in October of 1989 and had lasted 14 years, with the mission ending of September of 2003. You can see the course that Galileo took in the top left there on its way to Jupiter. And the end of the mission, Galileo had run out of fuel. It would not have been able to exit Jupiter's orbit. So as to not collide with Europa and possibly contaminate any life on that planet, Galileo was deliberately launched into Jupiter. Key discoveries of this mission include a lot of what we've talked about previous in the video here, including the existence of Europa's ocean under its icy surface, the saltwater bodies present on Ganymede and Callisto, Io's extensive volcanic activity, as well as Ganymede's magnetic field. So what about the future? We know all about these, quite a bit of information about these moons now. But what were we going to do with that? Of course, the most interesting discovery would be the possibility of life on Europa. So, of course, NASA would take advantage of that and is looking to launch the Europa Clipper mission in October of next year, 2024. It is expected to reach its target or target Jupiter, which it will orbit in 2030. This mission is to be a reconnaissance mission to learn more about Europa, possibly the extraterrestrial life there, which would be quite the exciting discovery for the scientific community. That is my video. Thank you for watching.